Hello friends, in this video we'll learn a concept of convolution. Let us begin. To understand a concept of convolution, I have taken an LTI system here. When I say LTI system, it means it is a system having two inherent properties, that is linearity property along with time invariant property. Remember, these two properties are different, but if both the properties are present in a particular system, that is, if a system is linear as well as time invariant in nature, then the system is said to be LTI system, that is linear and time invariant system. According to linear system, it must satisfy two properties, that is additivity property along with the homogeneity property. Whereas according to time invariant system, a system whose parameter does not change with respect to time or properties of the system remain same with respect to time, then the respective system is said to be a time invariant system. So now we have an LTI system here, to which, for example, we apply an input, that is del of n. Then we know that output is said to be h of n. And we know very well what del of n means. Del of n stands for a unit impulse input. To unit impulse, LTI system responses with the help of impulse response. In fact, output of del of n is called as h of n, that is impulse response. So for del of n, we have h of n as output. For example, if I change my input from del of n to, let's say, del of n minus 1, right? Because of the time invariant property, if input is delayed by 1, then the output is also get delayed by 1. That's what we call as a time invariance property. So for del of n, if I'm getting h of n, then for del of n minus 1, I must get h of n minus 1 as output, right? Similarly, if I apply input as del of n minus 2 to same LTI system, then because of which it is a time invariant system, output will also get delayed by 2, that is h of n minus 2. If I give an input as del of n minus 3, then the output would be h of n minus 3 and so on. Now this would be never ending, right? Now it depends by how much amount you delay your input, you get exactly same output but in a delayed version. Again, it is not only true for delaying. Suppose instead of delaying you have advanced your input, then the respective output also gets advanced by the same amount. For example, again for del of n, if you are getting h of n, then for del of n plus 1 you must get h of n plus 1 from the system. Similarly, if you apply an input as del of n plus 2, then output also gets advanced by 2. So this is the same LTI system for which I have applied different set of impulse input, for which I got different set of impulse response. What I can conclude from this, if I give a delayed version of impulse input, then you get delayed version of impulse response. Similarly, if you give advanced version of impulse input, then you get advanced version of impulse response, that is h of n plus 1 for del of n plus 1 or h of n plus 2 for del of n plus 2 and so on. So this is what we call as a time invariant property. But along with time invariant property, it is also a linear system. And according to linear system, we know that it satisfies a homogeneity property. So what is meant by homogeneity property? See, for example, now we know that for del of n, you are getting h of n. But suppose I multiply this del of n with k. Then by homogeneity property, we know that if input gets multiplied with some constant, output also gets multiplied by the same constant. So for k del of n, you will get k h of n as output. Is that right? So this k can be anything. So for simplicity, what I'll do, I'll be replacing this k with some other constant. So what I'll do is, I'll give x of 0 here. So if I multiply del of n with x of 0, then output also gets multiplied by the same, that is x of 0. Similarly, for del of n minus 1, when I'm getting h of n minus 1, then for x of 1 times del of n minus 1, I'll be getting x of 1 times h of n minus 2. Similarly, for del of n minus 2, we know that I'm getting h of n minus 2. So for x of 2 times del of n minus 2 will give you x of 2 times h of n minus 2. Similarly, x of 3 times del of n minus 3 will produce, of course, x of 3 times h of n minus 3. And it is applicable for advanced pulses also, or advanced impulses also. That is, suppose if I multiply del of n plus 1 with x of minus 1, and then if I apply to LTI system, then the respective output is x of minus 1 times h of n plus 1. Similarly, if I provide x of 2 dot del of n plus 2 as input to the same LTI system, then the respective output would be same, that is x of 2 times h of n plus 2. So in a way, it is proof that it is a time invariant system along with it is a linear system. According to the linearity property, we also saw that a homogeneity property is also getting satisfied. But for system to be linear, we know that one more property should get satisfied, that is what we call as a additivity property. So now here we are applying different inputs, and for every input I'm getting some distinct output. But for example, if I add all of them and if I'm applying this as input to LTI system, then output will be summation of individual responses. Is that right? So what I'm doing now, I can express this as my whole input. So by additivity principle, if I'm giving this summations of different inputs, then at output I'll be getting summation of individual responses, and that's what we called as a additivity property. So now we have seen that it is satisfying homogeneity principle along with additivity property, therefore it is linear system also. So now I can express my inputs as x of k dot del of n minus k, where k is varied here from, let's say, minus 2 to plus 3. So what we have here, not x of 2 but x of minus 2. So of course this has to get replaced with x of minus 2 here, right? So here I'm varying my k from minus 2 to 3, and this is what we called as Rx of n. Is that right? So what I did is I have expressed my x of n as summation k is varied from minus 2 to plus 3 x of k del of n minus k. If you can see here, what I've done, I have expressed all of them in single summation like this. And as you can see, a sample position is moved from minus 2 to plus 3. Reason, in our example, it is going from x of minus 2, and the last sample we have taken is x of 3. Is that right? So this I can consider my x of n. Similarly, I can represent my y of n is also summation of impulse responses like this. As you can see here, this is your y of n. So y of n can also be expressed as summation in terms of x of k and h of n minus k. So I can express my y of n as, again, k will be varied from same limit, that is minus 2 to plus 3 x of k, but we know that for del of n minus k you will get a response as h of n minus k. Is that right? But you know what, right now we are varying our sample positions from minus 2 to plus 3. That's not the case every time. That again depends upon the given problem, that depends upon the number of samples present in the given sequence x of n. Therefore, if I want to write this in general, so I'll be writing in a same form, but only thing, to make it quite in general, I can write my x of n as summation. Now instead of moving from minus 2 to plus 3, we will in general move from minus infinity to plus infinity. I can say x of k del of n minus k as input, and similarly our output y of n can be expressed in general as y of n is equal to summation k is moved from minus infinity to plus infinity, or k is varied from minus infinity to plus infinity, x of k. We know that for del of n minus k, what we get response as h of n minus k. Is that right? So see, this response, that is output response y of n, is very important, which I'm highlighting now. In this case, this y of n is what we called as output response. So let me tell you, this y of n is expressed in terms of input x of k and impulse response, that is h of n minus k. This is what we call as a convolution relation. That is, let me say this is equation number 1, or if you want to simplify this equation 1, you can write it like this: y of n is equal to x of n convolution with h of n. This y of n is called as output response. This x of n is called as input sequence, and h of n is called as impulse response. That is, this sign is very important. This operator is known as a convolution operator. And if you want to really get what is output response, if x of n along with h of n is known to you, you have to perform a convolution. And to get convolution, you write a convolution formula like this: y of n, which is equal to summation k is varied over minus infinity to plus infinity, x of k h of n minus k. So this becomes in fact a formula of convolution. So remember, if input sequence is known to you, if impulse response is known to you, and if you want to get what is output response, the simple relation is y of n is equal to x of n convolution with h of n. And to express in the form of formula, you write it like this: y of n is equal to summation k is varied over minus infinity to plus infinity, x of k h of n minus k. So after all, what is exactly meant by convolution? See, for a given LTI system, let's say h of n is known to me. Mark my words what I say. For a particular LTI system, you know what is h of n is. H of n is what? Impulse response. So for that LTI system, assume that you know what is h of n. Let's say now you are applying some x of n as input, and you want to predict what is the output y of n. Then you can express y of n is equal to x of n convolution with h of n, because x of n is something that you are going to apply, so you know what your input sequence is, and h of n is something which is already known to you, that is what we call as an impulse response. So if impulse response is known to you, you can determine what is output y of n as y of n is equal to x of n convolution with h of n. And if you want to perform this convolution, you have to follow this formula, which is y of n is equal to summation k is varied from minus infinity to plus infinity, x of k h of n minus k. So this is the formula to perform convolution in discrete time system. Of course, we are going to see how to perform convolution when it comes to continuous time also. So remember, this convolution is nothing but expressing your output in the form of summation of shifted impulse responses. So let me just go back to the previous slide so as to make you understand what the exactly convolution is. So as we have seen here, for individual input, we have seen how do we get individual output. Since it is a linear system, it is bound to follow additivity property. So when I'm adding all these responses, let me correct. If I add all these inputs together, then output will be addition of these responses. Am I right? So what convolution really says that if you express your inputs in the form of shifted input impulses, I repeat my statement, if you express your input x of n as a summation of shifted input impulses, then output can also be expressed as summation of shifted impulse responses. So as I said, meaning of convolution is if the input is expressed as summation of shifted impulses. That is, if you remember, we have expressed our x of n as summation k is varied from minus infinity to plus infinity, x of k del of n minus k. This is how we have expressed our input x of n as summation of shifted input impulses. In that case, output is, so we have to say then output is expressed as summation of shifted. So at input, if we have shifted impulses, then at output we will have shifted impulse responses. So if inputs are expressed in the form of summation, then output can also be expressed as summation of shifted impulse responses of individual input. Therefore, I can express my y of n as summation k is varied from minus infinity to infinity. We know that if input is del of n minus k, output is h of n minus k. And if del of n minus k is multiplied with x of k, then output also gets multiplied with x of k by homogeneity property. Is that right? And by linearity property, that is additivity property, if input is expressed as in the form of summation, output can also expressed as a part of summation or in the form of summation. So that's the whole idea of convolution. So convolution is quite simple. The only thing, if you understand a basic concept, then it becomes very easy to deal with this convolution. This convolution is very important topic from gate point of view. Thank you.